Good afternoon. My name is Timothy O'Brien, and I'm a fisheries biologist with the U.S. Geological Survey's Great Lakes Science Center. Today, I'd like to provide an update on the status and trends of preyfish populations in Lake Huron. First, I'd like to start out by acknowledging my co-authors. I'd also like to acknowledge a number of other staff that were important to the completion of this work in 2024. Preyfish serve a critical role in aquatic food webs. First, as an ecological role, they are a key forage for predator fish and birds. They transfer nutrients from plankton to predators and serve as secondary consumers within the food web. Preyfish also serve a societal role in aquatic food webs. First, they're food for economically important species that make up both recreational and commercial fisheries. In some cases, preyfish are harvested commercially. Species like cisco and rainbow smelt. And so assessment of preyfish stocks is important. First, for monitoring their abundance from year to year, but also their status provides us a measure of ecosystem health. Kind of thinking back to that food web model, again serving an intermediate role in transferring nutrients from lower trophic levels to top level predators. U.S. Geological Survey preyfish assessments are used to describe trends in species composition, relative abundance, as well as size and age structure of important fish species. We use two different surveys to assess the preyfish in Lake Huron. First, our traditional method is the bottom trawl survey, and secondly, our integrated acoustic and midwater trawl survey. These two surveys target different fish guilds. The bottom trawl survey targets demersal species, or those that are most closely associated with or residing on the lake bottom. The acoustic survey targets pelagic species, and those that are distributed throughout the water column. The acoustic survey is considered our whole lake survey in that it covers all the three major basins of Lake Huron, and this time series is 20 years old. The bottom trawl survey, which covers the main basin only, is a much longer time series, and that's approaching 50 years in length. And it's important to point out that survey data are considered population indices rather than absolute abundance estimates. Just a couple notes before we get going. The geographic focus will be the main basin. However, we also have some comparison to Georgian Bay and the North Channel from the acoustic surveys. For community metrics, we'll be using species biomass expressed as kilograms per hectare. For the individual species abundance, for yearling and older fish, this will be biomass in kilos per hectare. And for year class strength, this will be shown as density or number of fish per hectare for our young of year individuals. And so this year class strength index is normalized by maximum observed density, and this index ranges from 0 to 1. Any fish age information will be based on otolith ages. So the 2024 preyfish surveys had good coverage throughout Lake Huron, as shown here on the survey map. The acoustic survey was carried out between the 4th and 22nd of September. We did sample all three basins. 22 acoustic transects and 38 midwater trawl tows were completed throughout the course of the survey. The bottom trawl survey, which occurs later in October, we were able to sample 6 of 6 standard ports and all of our traditional bottom trawl depths and tows from 9 to 110 meters. Now getting to some of the results. So first off, from the acoustic survey and looking at the species composition and biomass across the three basins in Lake Huron. So starting on the left side with the main basin, generally since 2004, we've seen this gradual increase in biomass of bloater. Bloater do dominate the main basin offshore fish community. We can also see that rainbow smelt, to a lesser degree in some years cisco, and other species make up much smaller proportion of biomass. In the last couple of years, we have seen a slight downward trend in bloater biomass in the main basin. Moving to the middle plot, the North Channel has much more variable biomass across the 20-year time series, but can achieve much higher biomass levels. Much of this is driven by rainbow smelt populations, which are abundant in the North Channel. Although it's important to point out that in recent years, we've seen this increase in cisco biomass. And in some years, in 2024 in particular, cisco make up a fairly large portion of the North Channel biomass. Georgian Bay is a bit of a hybrid between the main basin and the North Channel. We have deep habitat that's suitable for bloater, but it also has nearshore areas that are very suitable for rainbow smelt populations. So we tend to see a little bit of a mixture of both. In 2024, this was dominated by rainbow smelt, and we did see generally an increase from 2023 in Georgian Bay. Moving to the species composition that we see in the bottom trawl, it's helpful to look at the bottom trawl time series really in two different time periods. From 1976 through right around 2003, 2004, we refer to this as the historical time period. We can see that species like alewife and rainbow smelt were very abundant throughout the 1970s and through the 1990s. Bloater were also abundant at certain periods. And then our more contemporary time period, which began around 2004 and coincided with the collapse of alewife in Lake Huron, we've tended to see much lower biomass levels, some variation typically driven by bloater, but generally much lower in the last 20 years. Particular note here, and this is similar to the acoustic surveys, is that bloater tend to make up the largest proportion of the offshore biomass. In 2024, we can see that that was over 60% of the biomass was made up by bloater. Rainbow smelt also a fairly significant contributor, but it's important to note here round gobies contribution in 2024, and I'll get to that in a couple slides. But round goby were very abundant in 2024. Moving on to some of our species-specific results. So now looking at alewife, we've continued to see low numbers of yearling and older alewife in Lake Huron. And looking at the top panel here, this is our yearling and older biomass. The blue is acoustics, and bottom trawl is sort of the open circle. Generally, though, since alewife populations collapsed in 2003, 2004, we've seen this sustain very low levels of adult alewife biomass. Moving to our year class strength, we do see from the bottom trawl on the top and from acoustics on the bottom that in some years we do detect what appear to be decent year classes of alewife. We can see here in 2021 from the acoustic survey. However, it's important to point out that these are usually very localized, where high numbers of fish are caught in a very small area of the lake. This has not translated to any appreciable abundance increase in yearling and older fish. So alewife do remain at historically low levels since their populations collapsed in 2003. If we look at their age and size distribution, we can see that they still largely consist of age 0 fish. shown here in yellow. Large alewife, or yearling and older, have been nearly absent from surveys since 2015. Now, in 2024, we did find some adult alewife. All of these were ages 1 and 2, and this marked the second highest catch in the last decade. So small populations of adults do exist in Lake Huron, but these mostly remain below the detection limits of our surveys. Moving now to bloater. As I pointed out earlier, we have since around 2004 in both surveys, we've seen this increase in bloater biomass in Lake Huron. Both surveys are in pretty good agreement, especially for the last couple years here where we do see this slight downward trend in bloater biomass in the main basin. Now, bloater is a species that does routinely have what we would consider relatively large year classes, and that is what sustained this general increase over the last 20 years. We can see both surveys tend to see these recruitment events, although it seems to be probably the acoustic survey shown on bottom where we see better concordance with the increase in adult biomass in following years. Important in 2024, we saw very low numbers of yearling fish, young year fish, and an indication of very low poor year class. Now looking at the spatial distribution of bloater, they do remain the most abundant species in the offshore preyfish community. And their long-term distribution, shown here by this map, which shows the interpolated areas are the 20-year mean from our time series. And this seems to be characterized by a northern stock and a southern stock in Lake Huron. And whether or not these are metapopulations or not, we don't know. But we've seen this pretty consistent pattern where we tend to see in the late summer, early fall, we see these large aggregations, one in the south and one in the north. In 2024, the highest biomass we found was more in the north between Hammond Bay and Thunder Bay, and that's shown here by the purple circles. If we look at bloater size and age distribution, we can see here from 2024, again, evidence of low numbers of age 0 fish. This is a result of a poor year class. However, biomass is distributed among multiple age groups. The median age of the population did increase from 2 to 3 for the first time in the last decade, and fish aged 2 to 5 made up the majority of the population in 2024. We can see, for instance, in 2023, where we did see a decent recruitment event, how that's absent from the 2024 age distribution. Now moving to rainbow smelt. So rainbow smelt have a very similar pattern to alewife in the main basin of Lake Huron. They were very abundant historically, and then we saw very low numbers in more recent years. We also tend to see semi-regular recruitment events in Lake Huron, although rainbow smelt also appeared to have very poor year class strength in 2024. And while this more contemporary time period does appear to be at or very close to zero, if we do zoom in a little bit here, we can see that rainbow smelt are still very abundant in some areas of the lake, although much lower than they were historically. Now moving to the spatial distribution of rainbow smelt. As we can see, they are widespread in Lake Huron despite their considerable decline in biomass over the past several decades. Their abundance has typically been highest in the North Channel and Georgian Bay, as shown here again in our map. These areas are very productive, particularly the North Channel, which has taken on more of a mesotrophic characteristic over the last several decades. However, in 2024, we did see the highest biomass in northern Georgian Bay. And in a lot of ways, this area of Georgian Bay resembles what we see in the North Channel, especially in the nearshore areas. Fairly high productivity. We tend to see decent numbers of rainbow smelt and cisco and a number of other species in these productive shallow nearshore areas. Most individuals, however, were greater than 100 millimeters. So again, kind of just showing that absence of a strong year class in 2024. We look at cisco abundance from our acoustic surveys, looking first at Georgian Bay on the left and North Channel on the right. In Georgian Bay, biomass has tended to fluctuate quite a bit, and it oftentimes seems to be related to how much nearshore sampling we're able to do in a particular year, as cisco tend to be more related to nearshore areas. In the North Channel, however, since around 2015, we've seen more of this sustained increase in numbers of cisco. And again, these can be highly variable. Oftentimes from trawl to trawl, we see a lot of variation in the number of cisco that we're catching, but generally we've seen this increase in the North Channel over time. Cisco are a species of conservation interest in Lake Huron and across the Great Lakes, and particularly in Lake Huron, where we have active reintroduction efforts that are underway in west central Lake Huron. However, present cisco populations are distributed in the North Channel and Georgian Bay, but also areas in the main basin, shown here, that are adjacent to the Manitoulin archipelago. Almost all cisco captured in acoustic surveys are adults. For instance, in 2024, the median total length was 352 millimeters. Again, we have seen generally an increase in abundance in the North Channel since around 2015. And in terms of stocked cisco in Lake Huron, these have not been detected in our acoustic surveys to date. Now looking at some results from species that are only captured in the bottom trawl survey, starting off with our sculpin species. Native sculpins first peaked in abundance in the late 1990s. However, populations started to decline in the early 2000s, and really for the last several decades have remained at low abundance. The sculpin community in Lake Huron does consist mainly of deep water sculpin. In fact, slimy sculpins have become increasingly rare over time, with several years them being entirely absent from the surveys. Since 2021, the biomass of both species has increased marginally. Due to the scale here, we really can only see this in the deep water sculpin, but that is some good news that we've seen a slight increase in this species for the first time in the last couple years. Round goby were first captured in bottom trawls in the late 1990s. In 2024, as I pointed out earlier, we did see a record increase in round goby biomass. This was over 1.5 kilos per hectare, and this was the highest in the entire time series. This marks nearly twofold increase from the second highest biomass estimate from 2022. We saw most of the increase in goby populations apparent from Alpena south to Harbor Beach. Now, just to summarize, so we do have some positive trends in species that are important to conservation in Lake Huron, most notably our native cragganine species. So bloater, for instance, have remained mostly stable in the main basin of Lake Huron. Now, I have seen a slight downward trend in the last few years, but for the most part, they have remained stable. Cisco have increased in the North Channel since around 2015. Historically high abundance of round goby does remain a concern for some of our native demersal species, like slimy sculpin, that are already at record low abundance. And we know there are some evidence that these species compete. Offshore preyfish diversity does remain low in Lake Huron, and this can lead to the potential for system instability. Consistent abundance trends, however, for some species, like bloater, indicate that preyfish populations are matched to primary production and predator demands. Thank you for your time today.